Hello Algebra 1 students, welcome to today's lesson. Today we're just going to do a little quick review of solving quadratics by factoring. In the previous lesson you watched a video on notes on how to do this. Today I would just like to do a couple quick questions as a refresher, and then I'm going to give you some problems to do on Delta Math to get some practice yourself. So let's go ahead and just jump into this example here. So it says solve the quadratics here by factoring. So again, factoring is something we did all of last unit, so this is something we should be very familiar with. Remember, when we're solving a quadratic, right, we're solving some sort of equation, we have to make sure before we start factoring that it's always set equal to 0, which in this case it is, so we're in a good place. Another thing we have to do before we start factoring, this is something we learned last unit, is we have to check to make sure that there's no greatest common factor we can pull out first, which in this case there's not, so that means I get to go straight to my x and start the factoring process. Again, if you like to do this and I like to do this, I like to label my terms a, b, and c. I know for the top of my x I have to take a times c. A here is my leading coefficient, which is 1, so I take 1 times negative 12, which is a negative 12. B goes on the bottom, b is a negative 1. So I have to find two numbers that multiply to a negative 12 but add up to a negative 1. It looks like to me those terms are going to be negative 4 and 3. Again, always double check your x. Negative 4 times 3 is a negative 12. Negative 4 plus 3 is a negative 1. So from here, once I have my x completed, I get to go to my box. Remember, I always say put the first term in the first box. So my first term here is x squared. Put your last term in your last box. The last term here is a negative 12. And then I fill in my two terms for my x in these boxes. So I have a negative 4x and a 3x. Again, remember I put x's on there because I'm just replacing this middle term. So instead of a negative 1x, I put negative 4x and 3x, which is the same thing if I were to add them together. From here, I just pull up my greatest common factor out of each column and each row. So it looks like this first column, I can pull out just an x. Looking at this next column, first off, I notice the box closest to where I'm pulling it out is negative, so I know what I pull out is going to be negative. And the greatest number that divides into 4 and into 12 is, in fact, 4. Again, now I'm going to look at this first row. Looks like I can pull out an x. Looking at this last row, it looks like I can pull out a 3. As always, when you're done, check your multiplication. Is x times x, x squared. Is x times negative 4, negative 4x. Is 3 times x, 3x. Is 3 times negative 4, negative 12, which in fact looks like everything works out. So I think I've done everything correctly so far. So from here, I'm going to go ahead and rewrite my quadratic in factored form. So instead of x squared minus x minus 12, I'm going to rewrite it as x minus 4 times x plus 3. Again, this is all still set equal to 0. We then talked about, in our last set of notes, the zero product property, which says in order for this whole thing to be 0, at least one of my factors has to be 0. So either x minus 4 has to be equal to 0 or x plus 3 has to be equal to 0. So to find my solutions to my quadratic, I just set each factor equal to 0. So I'd say x minus 4 equals 0 and x plus 3 would equal 0. Nice thing is that at this point we just solve these one-step equations, which are pretty slick. So it looks like one of my solutions is x equal to 4. And my other solution would be x is equal to negative 3. So those are the two solutions to my quadratic. So again, if I wanted to check my answers, what I could do is I could take x equal to 4 and I'd plug that into x in every place in this equation. And when I do that, I should get 0. Same thing if I were to plug in negative 3. Just as a quick reminder here, I guess before we move on, remember solutions to a quadratic are where they cross the x-axis. So what these two values are right here, they're really just x, my two x-intercepts, right? That's where my solutions are for my quadratic on my graph. So we say x is 4 and x is negative 3, but just remember these are x-intercepts, so there really are points, Right, it's really the 0.40 is a solution and negative 30 is a solution, right? Because they're points on my graph. But I'm okay for right now if you just said 4 and negative 3. So here's the first example. I'd like to do one more. You should notice something right off the bat with this problem, that something's not quite right. Hopefully you see that it's not set equal to 0, so we need to do that first. Set the quadratic equal to 0. So I subtract that 2 to the other side. Now it's set equal to 0. So now I have to go ahead and factor. Again, before you factor, you should be thinking, well, is there a greatest common factor I can pull out? It does not seem to be the case on this one either, so I can go straight to my x. Again, I'm going to label a, b, and c. A times c for the top, so I get negative 6 on the top. B on the bottom, which is negative 5. Got to think of two numbers that multiply to a negative 6 but add up to a negative 5. I believe those numbers are negative 6 and 1. Again, always double check your x, make sure that works out. Now I get to come make my box. First term in the first box, so I get 3x squared. Last term in the last box, that's the last term once I've set it equal to 0, so it's going to be a negative 2. The two terms for my x, negative 6x and 1x. Again, from here, I just go ahead, I pull out my greatest common factors. So if I just do that quickly here, looks like I can pull out an x. It's going to be negative because the box closest to where I'm pulling out is negative, and it looks like I can pull out a negative 2. This first row looks like I can pull out a 3x. This last row, just a 1. Again, check your multiplication. That's a great way to see if you've done everything correctly. In this case, it looks like it does work out. So now I just go ahead and rewrite my quadratic in factored form. So it'd be 3x plus 1 times x minus 2 set equal to 0. So again, from here, I just use that zero product property, which says in order for this whole thing to be 0, at least one of the factors has to be 0. So either 3x plus 1 has to be 0 or x minus 2 has to be 0. So I'm just going to set them each equal to 0. So I get 3x plus 1 equals 0 or x minus 2 equals 0. Just solve each of these for x. So on this one, it looks like I'm going to subtract 1 first. So I get 3x equals negative 1, divide by 3, scroll up just a little bit. Looks like I get x equals a negative 1/3. Over here, same story, I'm going to add 2 to the other side. So it looks like for this one, it looks like my solution is going to be x equals 2. So my two solutions are x equal to negative 1/3, x equals 2. Again, if you wanted to, you could plug those back in to make sure that it does in fact give you 0 in the end if you plugged it in right up here. So this was just a quick review on solving by factoring. Hopefully this was a nice refresher for you. Now that you've watched this video, you get points for just doing that. And make sure you go log on to Delta Math and do those practice problems that I have assigned for you. As always, if you have questions, make sure you shoot me an email at storeandflip@gmail.com. Otherwise, have a fantastic day.